These are notes for Advanced Math, Unit 3, Lesson 4. Okay, this is 3-4, trig functions of special angles in quadrant 1. We will be learning quadrants 2, 3, and 4 tomorrow. All right, first part, actually this is all review, but the first part is review from Math 2. Okay, I'm going to draw a 30, 60, 90. This is also a 30, 60, 90, but I'm just going to put it where it's 60, 30, 90. Same type of triangle, just flipped around. And the next one I'm going to draw is the 45, 45, 90. All right, your Math 2 teachers taught you that this was opposite the 30 was A, hypotenuse was 2A, and opposite the 60 degrees was the A root 3. On this one, same thing. Opposite the 30 is A, the hypotenuse is 2A, and opposite the 60 is A root 3. And on the 45, 45, 90 was A root 2. A root 2. All right, so what we're going to do is change this so that we are dealing with unit circles. So I'm just going to quickly redraw each one and talk about what would happen. Let me get these angles in first. 30, 60, 90, 60, 30, 90, 45, 45, 90. And I'm just going to redraw this one just a little bit so it can look more like we have a longer side and a short side. Okay, here's the 60 opposite the long side, and here's the 30 opposite the short side. All right, so what we want is, remember we talked the other day about a unit circle, and a unit circle has a radius that is 1. The radius is 1. Now when I draw these, well, if you look, when you draw your right triangle, the radius is the hypotenuse. So I want the hypotenuse in each one of these triangles to be 1. So if I want this to be 1, can you see that I would divide everything by 2a? Why 2a? Because I want 2a divided by 2a to be 1. And what I do to one side of the triangle, I must do all the way around to keep it consistent. So a over 2a, the a's reduce, and this is 1/2. A root 3 over 2a, the a's reduce, so it's root 3 over 2. And the same thing here, I'm going to divide everything by the 2a and reduce. A's reduce, root 3 over 2, a's reduce, 1/2. So don't know if you remember this from last year, but this is where your unit circles came from, the root 3 over 2 and the 1/2, the 1/2 and the root 3 over 2. Can you see that this is your long side and this is your short side? And this is your short side when you're dealing it with the 60 being at the base. This is your short side. What happens to be the same short side as the 30 being at the base, and this is your long side. Again, which happens to be the same as the long side here. Okay, this one we're going to divide everything by a root 2, not 2a. I'm dividing by a root 2 so that can reduce to 1. So dividing everything by a root 2, And you can see that in both of these sides, the a's are going to reduce, leaving us with 1 over root 2. 1 over root 2, the hypotenuse is 1 there and there. Now, I don't know if any of your teachers called this root 2 over 2, which is the same thing. In my class, I'm going to leave it as 1 over root 2. You're more than welcome to change it to root 2 over 2 if you'd like. All right, so how does this apply to the unit circle? All right, I'm just going to draw a semicircle. And this semicircle, even though I drew it in quadrants 1 and 2, I'm only dealing with quadrants 1 today. Only dealing with quadrant 1. We will deal with the other quadrants another day. Okay, what we're going to draw is our 30 degrees, our 45 degrees, and our 60 degrees. Okay, so let's see if I can get this done. Here's my 30. I'll darken this one in this bluish color. And I'm going to draw it here. This is the hypotenuse is my terminal side, and I'm dropping down to the x-axis like I told you guys we always would. So this is 30 degrees. And on a 30 degrees, remember the hypotenuse will always be 1 because we're dealing with the unit circle. The long side will be root 3 over 2, and the short side is going to be the 1/2. Now when you write this as an ordered pair, because you will, you went to the right root 3 over 2 and up 1/2, so it's root 3 over 2 comma 1/2. The next one I'm going to put in orange. This is going to be my, and I apologize, this is not going to be my next one. That'll be my last one. I'll leave it in orange, but I do want to do the 45-45 only because that comes next in order. Let me get a different color. I'll do this one in the magenta color. This is the 45-45-90. I only want to do that one second because it in order 30, 45, 60. So it's harder to write the angles in there now, but this here is the 45 degrees. And you know with the 45-45-90 the legs are the same, 1 over root 2 and 1 over root 2. Okay, so this ordered pair, again, I can't list them all on here because it's going to get really messy, but you can tell that I went right 1 over root 2 and up 1 over root 2. So my ordered pair would be 1 over root 2, comma 1 over root 2. Going back to my orange one, now my terminal side here, this is a 60-degree angle. There's a 60-degree angle. I'm going to drop down to my x-axis to make my right angle. I'm going to go back and put it on my 45 triangle. All right, I made my right triangle. Now if you look, now at the base is the short side and then the long side, and short side is the 1/2 and long side is root 3 over 2. All right, and that is the basis for our unit circle. This right here is what we're going to be using in all 4 quadrants. Root 3 over 2, 1/2, 1 over root 2, 1 over root 2, 1/2, and root 3 over 2. We're going to replicate that in quadrant 2, in quadrant 3, in quadrant 4. Signs will change because you're going to be going left and then up, so some are negative. You go left and down, so both are negative. Right and down, so some are negative. So again, we'll adjust that on our next lesson. Okay, let's quickly get some facts down here. These facts I'm about to write for you again are still review because you did do this last year. All right, what is sine of 30 degrees? What is cosine of 30 degrees? And what is tangent of 30 degrees? All right, sine of 30. 30 is my little blue triangle, and sine is opposite over hypotenuse. 1/2 over 1 is just 1/2. Cosine of 30, cosine's adjacent over hypotenuse, so root 3 over 2 over 1 is root 3 over 2. Tangent of my little blue triangle is opposite over adjacent. I'll do that work over here. Tangent of 30 is opposite, which is 1/2, over adjacent, which is root 3 over 2. Do you see that? Opposite over adjacent. If that's too small, you can see it here. Opposite of 30 is 1/2. Adjacent's root 3 over 2. So that is 1/2 times 2 over root 3. Reduce, reduce, and it equals 1 over root 3. So tangent of 30 is 1 over root 3. All right, sine, cosine, and tangent of 45. All right, sine of 45 is opposite over hypotenuse, and again we can look at this picture if it helps. 1 over root 2 over 1 is 1 over root 2. Cosine is adjacent over hypotenuse. 1 over root 2 over 1 is still 1 over root 2. And tangent is opposite over adjacent. I'm not going to show that because I'm hoping you can recognize that 1 over root 2 divided by 1 over root 2 is just 1. All right, sine, cosine, and tangent of 60 degrees. Now, I'm hoping you already have these memorized, or there's somewhere in there that you have that you just need to dust off and work on rememorizing because you did this last year. I don't know why I put the equal signs, sorry. Sine of 60 degrees, cosine of 60 degrees, and tangent of 60, not equals. Okay. All right. Sine of 60, again, if it's hard, because I didn't label these sides, you can read this one. Sine is opposite, which is the long side, over hypotenuse, so root 3 over 2 over 1 is root 3 over 2. Cosine of 60, cosine's the adjacent, which is the short side, 1/2 over 1, which is 1/2. And tangent of 60, I'll do that one here. Tangent of 60 equals opposite over adjacent, root 3 over 2 divided by 1/2. Long side over short side, which is root 3 over 2 times 2 over 1, which reduces to simply root 3. So I'm going to erase that fraction or white out. Root 3 over 1 is just root 3. All right, these are ones you definitely want to work on rememorizing because you already have them in there somewhere. You worked on this last year a whole lot. You want this set memorized, and then we want to extend this memorization into quadrants 2, 3, and 4 on the next lesson. All right, quickly, what you should have noticed is that cosine is always the x values. Look at cosine 30, it's the x value. Cosine 45, x and y value are the same, but it's the x value. And cosine of 60 is 1/2, that is the x value. You may have known that already from last year. Sine of 30 is 1/2, it's the y value. Cosine 45 is 1 over root 2, the y value. And cosine of 60 is, sine is what I was working on. Try that again. Sine of 30 is 1/2, sine of 45 is 1 over root 2, and sine of 60 is root 3 over 2. All right, so let's write that down, even though you already know it. Cosine 30 is always going to be your x value, and I don't know if I said 30, but that's theta. Sine of theta equals the y value, and tan of theta equals the y over x value. And I didn't say that earlier, but you can see that tan of 30 is y over x, 1/2 over root 3 over 2. Tangent of 60, that's the orange one, was root 3 over 2 over 1/2, that's y over x. So again, stuff you should know from last year. Other stuff you should know from last year that we're going to use a lot of: 30 degrees, 60 degrees, 45 degrees. 30 degrees always equals pi over 6. 60 degrees is always pi over 3. And 45 is always pi over 4. And if you don't remember that, you can always go back to your conversion stuff that we did. I believe it was lesson 2, where if you want to change from degrees to radians, you multiply by pi radians over 180. And if you did that, you can see your degrees are going to cancel out. Your zeros will cancel out. 3 goes into 18 6 times. So you end up with pi over 6 radians. Again, you don't have to do this every single time because I'm hoping you already have these memorized. If not, work on them. All right, fill in the blanks. Function. Theta in degrees, theta in radians, and function value. All right. First one I'm going to give you is sine for the function, 30 degrees, 30 for the degrees, and we want to find the radian value and the function value. All right. Working through. 30 degrees is pi over 6 in radians. You should have that memorized. If not, you convert it or look at your notes. Okay, sine of 30. Picture your 30 in your quadrant 1. If you have your notes, that's fine, but if you don't, try not to look back. Think of your 30 triangle. That's the one that's down below. So this is the short side and this is the long side. Sine is opposite over hypotenuse, so it would be the short side over the hypotenuse. So it's going to be the 1/2. Sine of 30, you can look back here to make sure, and sine of 30 is indeed the 1/2. All right, so that's it for that one. We have our theta in radians and we have our function value. The next one I'm going to give you is secant, and I'm going to give you that this is 45 degrees. What is 45 degrees in radians? Pi over 4. As a function value, secant's the reciprocal of cosine. And remember that cosine of 45 is 1 over root 2. So the reciprocal of 1 over root 2 is root 2. Again, you can look back here. 1 over root 2, reciprocal of 1 over root 2 is root 2 over 1. All right, next one I'm going to give you is cotangent. And I'm going to give you the answer over here. The function value is root 3 over 3. All right, so they're giving you the answer. So if they give you the function value, you're going to look back over here at the answers and work your way backwards. Now, think about what they gave you, though. They gave you root 3 over 3. Cotangent's the reciprocal of tangent. So if you flip this, you end up with 3 over root 3. Looking at our chart, do we have a root 3 over 3 or 3 over root 3 anywhere in this chart? We do not. So when you can't find the value in the chart, what you have to realize is that they've rationalized. Remember I said we will not, but textbooks still do it. So unrationalize, I know that sounds wonky and weird, but you unrationalize by multiplying top and bottom by root 3. Or you could flip it and then rationalize if that helps you. This is root 3 times root 3 is 3. 3 times root 3 is 3 root 3. Reduce the 3's. 1 over root 3 is equivalent to root 3 over 3. Most of you, some of you can probably do that in your head, like, oh, undo it and see. But remember, if this is cotangent, we don't have cotangent on our chart. We only have tangents. So you're thinking of, well, then that means tangent of theta must be root 3. All right, if cotangent theta is 1 over root 3, then tangent of theta must be root 3. So look back at your chart. There's one place where tangent is root 3. Can you find it? Tangent is root 3 at 60 degrees. Do you see that? Tangent is root 3, which means cotangent would be 1 over root 3. All right, so tangent of 60 is root 3, which is what we're looking for. So that means our angle here is 60 degrees, which means our theta is pi over 3. All right, last set, evaluate theta, theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. So this is telling us our angle measure is sandwiched between 0 and 90, which means we are in quadrant 1. It may not tell us that, but we should know this is implying that we are in quadrant 1. We will deal with quadrants 2, 3, and 4 another day. All right, number 1, sine of theta equals root 3 over 2. Sine of theta equals root 3 over 2. Try to do it in your head. Root 3 over 2 is the longer side. So on your unit circle, what sign is opposite? So this is the long side, would be the opposite when this angle in here is what? 60 degrees. And I'm going to have you give it in degrees and radians for now. 60 degrees. Put here, theta equals 60 degrees or pi over 3. You don't have to give 2 on on all the problems to come in the unit, but for today I'd like it. All right. If you didn't do it the way I did, then you come over here. When is sine root 3 over 2? Right here, and that's at 60 degrees. All right. Number 2, tan of theta equals 1. That should be the easiest one for you. There's only time when tangent of theta equals 1. And look at your chart if you're not sure. It is 45 degrees, which is the same as pi over 4. And number 3, secant of theta equals 2 over root 3. Now this one's tricky because secant we don't have in our chart, and don't know if you have them memorized already, but in your head, if you don't have it memorized, in your head you're processing secant's the reciprocal of cosine. So cosine theta equals root 3 over 2. Go ahead and find that one while I answer the phone. Thank you very much. Okay, bye-bye. All right. So Cosine, you're I'm sure are done by now, and you've looked at your chart. When is cosine root 3 over 2? So if you have it memorized, or if you're working on memorizing, root 3 over 2 is the long side, and cosine is the adjacent. So I'm just picturing the coordinate plane here. My triangle would be like this. Long side, short side, because cosine is the long side, and that happens at 30 degrees. Because it's the 60 degrees that has the short side here and the long side there. So my answer is theta equals 30 degrees, or pi over 6. Again, this was just trying to get you to do it in your head without having to look at the chart, because eventually you do want them memorized. So let's check. It was cosine theta equals root 3 over 2, and we can see it happens right here at 30 degrees, which is what we got, 30 degrees, or pi over 6. And that is it for this lesson.